moving from Virginia to New York, back to Virginia, back to Florida. I have all this medical records. I don't have to go into a doctor's office and start from ground zero with paperwork that says, who are you and have you had this surgery? It's all there, and I can just share that with someone. And they're working on something very similar. They're starting it on the student side, because the student side's a little bit easier to tackle than HIPAA and working on the healthcare side. But obviously the idea there is that the primary benefits is it allows public transparency around the topic. Public transparency is where it would come from, and it eliminates the ability to hack through because of tightening security. And the reason for that tightening security is that it is built in a block. And so the reason is it's kind of like a block that replicates. And so it's hard for someone to get in and figure out, what is this technology? Which block is it stored in? And really getting in to tighten it, because you ultimately have this idea of you have this a block that kind of comes together, and inside that block there's this transaction counter that's keeping up with every single time that it's being shared. Every time I'm sharing my education record, every time I'm sharing my health record with a third party, it's being shared, and it becomes digitally encrypted that, hey, it's been shared, so that record's not the same after being shared from what it was before in some respects. When you look at the overall bus of it, the entire model in which it's built. So you have these transactions that sit underneath a transaction counter. And so underneath that transaction counter, you have this block header. So you have these blocks that you can see here, and you can have many of these from an architectural standpoint when you have a record. So you as a student you would potentially say, okay, I've gone to Elon, I am a third year at Elon or a fourth year at Elon, and I'm ready to go on to law school. Rather, maybe you stay here, maybe you go to another law school. So you ultimately now have this record. So I've got my student record that from Elon, I may have some other things in there, which is the really neat thing about what they're looking to include with this is basically including into this education record, I want to put that I've volunteered at somewhere else, and I've done all of these things. So you created your own student portal, this beautiful package. You've done some internships and some jobs. Now you go to share this with a provider. The reason that this is hard for another third party to really get in there is it's something that I've directly shared with you, my record, and then the system is keeping track of that. And so what a lot of people use as comparison, which is not even close, is the idea of Google Docs. So I have a Google Doc and I want to share that Google Doc with you, so I give you permission to it. I either give you permission to read it or I give you permission to edit it. The one difference between Google Docs and using a true blockchain model is that every time I share that with someone, it's encrypted that this person now has access, and there's a digital signature behind that this person has access. When did they touch it and use that particular item? And if someone else has that particular block, I send that block to someone at my record, and then my record, they add something to it because I gave them permission. I said, I want to go to law school. Now they want to add their law school records to it. They build those on as blocks, so it becomes more like a series. So that series alone is constantly changing, so it's hard for someone to come in and say, I have the password to encrypt, to break into your system to actually manipulate and tweak around. But we'll talk about that. It's not completely secure. We'll talk about there is some options that become more secure, but you start to lose some of the benefits, obviously, as you tighten up security for it. Some of the characteristics is it allows some decentralization. So now this creates and probes problems in organizations. It does. So the decentralization of something, organizations start to ask questions, and we're going to look at one of the biggest questions they ask, which is, what's the total cost of ownership? Why do I invest in this technology? Because it's really something, it's a lot like Internet of Things is in the market, which is I can't physically own this. I give you access to your record, it's technically your record. So I create this for you, it's now yours. And so organizations are struggling with that because organizations oftentimes like to keep ownership of it and like to be able to say, I want to be the middleman that sits in the middle, that basically is the middleware that you tell me who to give access to, and I charge someone something for that. That type of model is really creating that decentralization. there's a validation that happens. So you tell them they have access to it. It works and goes much deeper than even digital keys in the old FTP model where I give someone my access and they use the same key over and over and over to access it. It's almost like I can say, I'm giving you access to this for 7 days. I'm giving you access to this for one transaction. I'm giving you access, so you get much deeper than that. The next one is it's somewhat anonymous from the idea that there's not an organization that's behind it, and this is what's created a lot of challenges in what people have known of as Bitcoin. So Bitcoin is just one example of a blockchain. So you have Bitcoins that are actually being used for transactions, and it's hard to trace back. It's all kept inside and locked in, but it's hard for someone from the outside to say, who all has had this before me, if they didn't make a contribution or make an addition to it. So if I'm using it for medical records and I go to 5 different physicians and I decide not to actually have anything performed by one of them, or maybe some of those are view only and don't have the ability to send back transactions into the blockchain, ultimately there's some anonymous factors there. I can give them access to it and have them look at it and say, here's my second opinion of what you have, but I don't have anything really, there's no additional medical records that I'm contributing to your files, for example. And then there's an audibility around, so the two of these are real, people say, gosh, that's misleading. There's anonymous, but then there's an audibility. The audibility is really around for the fact that you can lock down a blockchain and say no one has access to to tweak it, to change it. It's that edit versus read. And then if there's any edits into the actual document, into the record itself, all of those are kept in a very secure, and it's actually logged. They're scripted, that you can see, where this transaction came from, how it was added, was it requested to be added, those types of things, which a lot of people have a little concern with as well, because they feel like people have the ability to share what they want to share, but not everything is obviously one of the challenges people are saying with the blockchain. In some fields, not in all the fields. So really there's 3 types. So you have this truly nearly impossible to tamper is this public access blockchain. So there's 2 infrastructure types for it. There's a public, there's a consortium, and there's a private. So some organizations are really looking at this idea of, I want to have a blockchain to use internally for the purposes of, and it's a very concrete, described type of event that they want to build it for. I want to build it for legal purposes, or I may buy things abroad and bring them back, and I have my letters of credit in there. So I want to keep it very locked down, and it's going to be for my organization. What the result of that is, by having it private, the way they're building that blockchain out, there is an ability. That's the one that's the least in terms of your public is nearly impossible to tamper. If there's going to be any tampering, it's mainly you're going to build that more on a private side, because you're giving them a little bit more freedom in the facts that what you're giving them. You're giving people, it's typically you're giving this internally, you're giving this to people that you share directly with. I worked on a blockchain early on where it was a consortium, which it was basically it was JP Morgan Bank and Bank of America and Wells Fargo. They clear all their items as on us, meaning that they clear a check at Wells Fargo. If you write a check from JP Morgan and give it to a Wells Fargo customer, they will clear that check as if it was their own check. And they do that because the 3 of them have partnered together. And they created a partnership, and they've built, and one of the first blockchains that I worked on was in 2009 when we were building out, 2010, when we were building it out, and we built it on an infrastructure that wasn't blockchain originally, and then migrated it to blockchain in the 2013 timeframe. So what they've done is they created this partially centralization where they actually, all 3 of them have their ledgers, that they know exactly how much money to expect, so that, if I'm Bank of America, I'm going to clear your Wells Fargo checks, $20 million or $20 billion of your Wells Fargo checks on my bank, and I'm trusting that you're going to pay me back for that because we've reconciled this properly. But they've built that into a blockchain is one of the things they've used between the 3 of them, which creates this public access, or restricted, in their case, restricted to the 3 organizations that's playing in that space. So that's one of the things. And then obviously your public facing really is, people typically think public is the least secure, but in this particular request, you're enabling less people to, it's more of a read view is what really you're giving people the ability on, and it really becomes more of a public, decentralized, completely decentralized blockchain infrastructure from a comparison standpoint. Any questions thus far? We'll get a little bit deeper into it as well. So I always turn back to, I'm a former, I came out of Gartner. I was a research director for Gartner years ago under CEB's name, Corporate Executive Board. And so one of the things that Gartner does is they create these hype cycles. Now, we in business, they're really good for a lot of things, but they're, at the same time, some people look at them on the business side and they say, oh, these things are really neat and I like to see them, and I teach these in the big data course that we have here. We learn quite a bit about these hype cycles. But this idea is they actually built an entire one devoted to blockchain starting in the 2016 timeframe. And so now in 2018, what they do is they take all the different types of blockchain and they basically put these into a hype cycle. And they build their hype cycle in such a way that they look at this innovation trigger. It's just starting out, it's got a little bit of potential. People are starting to think about this type of a model. And then they put things into this peak. It kind of elevates, or they could start technically in peak of inflated expectations. And what that really is that people think it's going to solve everything for them. And then they start getting in there and they're like, oh, but you need this and you need that and you need these other tools to really make it successful. And then there's kind of the trough of disillusionment, and this is one that it really becomes hard, especially when we used to create hype cycles and we would put, none of these actually contain vendor names, but when we used to work with vendor names as the research director behind the scenes, I would come up with all this stuff and this is the answer and all these numbers, and the vendors, suppliers, partners, big customers of CEB and Gartner would come out and say, we've got all this money, can we not move backwards? So you don't see a lot. I always say this because I've seen the other side, but the trough of disillusionment really is, I've invested in something, I have not seen my return. I'm struggling to see it. And we'll talk about why they're not seeing their return in blockchain. It's one particular reason why that's there. And so, and one of those major reasons is that you can see Internet of Things is up there as well, and it's in the exact same spot. Both of blockchain and Internet of Things have that same position. And everybody kind of looks at it and says, gosh, everything has Internet of Things in it. But the real quest of the question is, who owns that data at the end of the day? And that's been the real challenge, is because Internet of Things is not owned by a person. You don't go to Samsung, who has their refrigerator, and say, give me your Internet of Things. It's something that's there to help improve their product base, but it's not something that one person owns, which we'll talk about that. So you see a lot of different options here. And then you have this sloth of enlightenment, which means, hey, we're coming around and we're going to make this work, and we're seeing a lot of neat other repurpose opportunities for the technology. Blockchain doesn't have a repurposed or a sloth of enlightenment because it's so new technology. So typically you give something about 5 to 10 years, probably in around 2022, you'll start to see a lot of things fall in that, which means it was originally created for this, but by the way, it really works in this, it works better for this other purpose. And then you have this plateau of productivity, meaning they're kind of out there using it. Your complementary currencies kind of in that space today. It's kind of been out the longest. I mean, blockchain and some of their other sisters have been out the longest. But some of the ones that you really pay particularly attention to, a lot of the ones that's in this innovation trigger, there's a lot of things that's in the innovation trigger that's kind of along the lines of this healthcare, kind of because people are now wanting their health records to be shared and be, the portability of a health record. They're kind of out there in that model. You have kind of this idea of advertising, which is one really big. What this is there's this idea, and there is a blockchain out there, and I know I owe some research to some colleagues, but ultimately there's some blockchain out there that's been built around advertising, which there's always been those organizations that hold your information. So they actually know that your income level is this, and like a great example of that is a company called New Star that you probably never heard of. stuff. They actually know who you are, but you may not know who they are. But they have a lot of information about you based out of the DC or DMV, Washington, DC area. But they kind of own on every Intel device on computers. They were really early to make really good friends and say, can I plug this little bit of technology onto these computers, which keeps track of all the information about people. The idea there is a blockchain for advertising. There's something very similar, which is an individual's prototype that's being maintained and being built and for advertising. So this is kind of what I like. My preferences are, to fly with this airline and to rent this rental car. Those types of things are being built out as an early innovation trigger. And there's a couple of providers that want to be leaders there. But really there's a lot in the healthcare that you can see. There's some in the insurance space, a lot in the supply chain. The one that I'm going to talk to you a good deal about today is education, and talk about kind of what we're doing. One of the big things and one of the biggest investments in the education space. And then there's obviously, if you move around, there's some peak of inflated expectations. There's some blockchain reward models that's out there, some coin offerings, and the government. There's a whole group around government. So you'll see some of those ideas. So really, what is the problem with blockchain and why has adoption been so slow? So adoption really came out in that 2009 was the early, invention of this blockchain. And now if you go to conferences, it's a big buzzword. A lot of people say we need to get into the blockchain, especially in academia. Corporations look at it and they say, I like the idea, but I'm really concerned about this total cost of ownership model. What is my total cost of this ownership? I'm going to build something out there and it can morph into something much, much, much larger. And then who's maintaining that infrastructure? Who's building on it? Who is actually keeping the lights on? And how do I get compensated for that? I'm going to build a prototype or I'm going to build a blockchain to share your student records so that you can share your student records with anybody. And we've got we've got wonderful funders that's willing to do that. That just has lots of money, that can play around with money and buy their kids in stables for graduation. But those types of things will go away, right? Corporations look at it and say, I want to know how much money I'm going to make from something. And so the first thing was in 2009 to about 2020. It was a lot longer. Originally, they estimated it would be 4 years. But this is kind of going into the same model. It was built to really around existing structures to reduce cost and friction. And so it was this idea of it cost a lot of money to move things. If you take something as fundamental as your healthcare records, if you move from California to North Carolina, or you're a student that actually has a home address in Connecticut and you're down here in school in North Carolina, you go and you have a flick sickness or a cold, you start over. And then you're asking them, hey, could you get my dental records? And they're sending it. There's a huge cost to that, and there's a friction to that. There's a little bit of that commercial that happens where your dentist back home may say, hey, I want to do that crown for them. Why don't you just wait till they come home for Thanksgiving? I'll take care of the crown. That's $1,000 back to the dentist that wants to do the crown versus letting you do your crown locally when you need your crown. So that kind of model, it really helps reduce the cost of faxing and emailing and requiring transactions. You technically, as the patient, are in ownership of your health records. So you should be able to say who you want to have access, and it should be somewhat urgent or instant who you give access to it. And so that's kind of one of those models around enabling technologies, but thinking about it from the physician side that says, okay, I've got to do a little bit of work to bridge, not much, just an API to bridge, to basically take something to be able to send over your data to this record. That costs a little bit of money, and organizations are saying, I know I'm going to get something back from this, but I also have a chance of potentially losing something in this respect. I could lose the ability of additional business that I could keep here by allowing them this open-ended. And it's characterized by this limited distribution. And that's kind of the whole sense of it. There's a network effect that has to happen. And what I mean by network effect is the more people that use something, the more people that want to get on it. LinkedIn is a great example of a network effect where you basically create your profile as a student. If you were the only person on LinkedIn, It wouldn't mean very much, but because you are on there with 2 billion other people, the idea there is that you can actually quickly share that with other people and it becomes valuable. So the very first was this enabling technologies. In 2016, we really started to see a shift. We started to see this change. It was really a redesign of the whole technology platform. And instead of making it feel a lot more like an open sourced blockchain technology that everybody in the world can just touch, feel, download, and do what they need to do with it, there was this really a redesign of it to really go after specific problems. So instead of leaving it open-ended, there was more specific problems around it, and it became more of a decentralized distribution. So really it was, people started to adopt it. So more legal has been a huge adopter. So if you share legal contracts, legal agreements is a huge adopter. So more decentralized, where it wasn't just this nebulous, anybody can go and get into the blockchain. It became more specialized into the industries. And then complete solutions is forecasted for a 2020, where you really start to get into more decentralization, more, looking at it from a technology stack, full-scale implementations across businesses. That's really where they forecast shifting it completely over. And then 2025 is kind of enhanced solutions, making it greater with larger transaction volumes. So they kind of, modified the original time frame, and now they're saying around 2025 is when you'll start to see many more transactions going through it versus being more exploratory. Any questions about FAD or future? Yes. So from a competitive nature, absolutely. And so that's one of the things, I think that's where it kind of gets into that network effect. If many of your peers sign up for something, it's kind of a known deal that in order to participate in this space, I have to invest in this, or I have to participate at least. There's not a huge investment, but there is some participation. So you're spot on. I mean, that's what will happen. But then, you need some incentivized for the early adopters really to push it so that it becomes more of a competitive nature. And so what's happened there is there's some nonprofits and there's some entities, and I think the government, which was on the forecast as well, government's looking at doing some things because they're trying to move more and more people to that model. And so then really the rules of engagement, there's 2 real rules to this engagement. Now this is the second reason. We talked total cost of ownership was a concern, and it was making adoption somewhat stagnant. What's my total adoption rates and things like that. There's 2 things here. One of those is the same problem that happens in IoT, Internet of Things. But it cannot be controlled by any single entity. So there's a lot of entities that wanted to first come out and say, hey, we're blockchain. We're using blockchain for something, for a particular purpose. But they wanted to control that particular purpose. So sometimes one of the things financial institutions were saying was they used to send organizations, they used to use, years ago, use T1, T2 lines, which is I have a direct underground cable to send you your bank transactions. That's how we used to send bank transactions, and not that long ago, early 90s. In this model, though, now everything has shifted over and it's all online. And everybody's kind of become, they've taken the flip side and said, oh, everything's online, it's so much easier. But the idea, though, is you can't say I'm going to give you your banking blockchain if I, the bank, is not controlling how that data is coming over to you. So that's kind of one of the biggest concerns with it, is this idea that there's, you cannot be controlled by a single entity. A blockchain relies on more of a decentralized infrastructure. Now, what organizations have done, and I know some have done a great job, SAS has done a good job, Microsoft has done a great job, they're attempting to, more and more organizations that's in technology are trying to get in there to say, how do we kind of make this so that it gets the benefits and it has all of the attributes of a blockchain for sharing and the ease of use, but still we have some influence. So they started changing words like control to influence. And it's a strong influence organizations are attempting to get in there. But if that one area could easily be amended somewhat so that it was more of an influence, I think we will see some more adoption. I mean, that's one of the reasons their adoption's been somewhat slow, is you're asking me to put $20 million into something that I don't have control over and don't see a future that I can do, that I can own this going forward. So that's one of the model. And then the other piece is that blockchain is built, which this is a rule of engagement, that it has no single point of failure. Now this is one people typically like. They like the no single point of failure because of the way that you build it out. It's resistant to cyber attacks, which every other technology is being attacked with, and it's one of the bigger components. But it has, what they've done is they built it in such a way that if you don't have one single entity that has complete control over it, and you build this more in a public type of a model, you lose the ability for more cyber attacks because it's constantly amending and changing, and you remove some single points of failure. That's what organizations are doing, and so they're kind of going from that angle. Where is blockchain? So this is one that I think a lot of people are hearing us talk about it, and they're like, okay, I can't see it, I can't feel it, I can't touch it, it's hard to understand it. Where you really see it is it's kind of along every industries are starting to play around in blockchain. So some of the things that probably are the more popular that we're seeing far, far more is in the upper right-hand corner, you actually see smart contracts in the upper circle, but there's the smart contracts. So two parties are basically creating contracts, and they're doing that through protocols that's actually allowing them, you can see here, between two or more parties, that's intermediaries. So this contracting is a really big area where you're seeing investment. R&D is definitely playing, a lot of research and development and organizations are playing around smart contracts. It's the one that they feel like feels very easy to basically understand, and it's one that they can easily see, hey, what do we have to lose of putting out a contract that's most likely public information in many respects anyways. And so once we see that, the other big piece is this your digital identity or your footprint, the Internet of Things. So its sister, basically, or brother, whatever way you want to look at it, Internet of Things that has a similar problem. They're kind of joining forces in some respect, and some people are looking at putting their Internet of Things, if they're already willing to put an investment into Internet of Things, they're also willing to put an investment into blockchain, so they're combining some of those. And there's secure voting systems is a great example of one of those. I mean, it would be, we hear about voting all the time in our media here, but there's an idea that there's a lot of work around voting. The registries, in the sense of basically building out and having every transaction, so what's the proof of existence? Again, a low risk. If you have, kind of from a registry of some sort. Internet of Things is building that digital identity, but they also have got their own area, property registration, things that's open to the public to see anyways. Just like you could go out and almost look up anyone that owns a home and see all of their public information. That some people hate that, and some people love that, but that's kind of a model. It's already there. It's already directory level information, so putting it in a public blockchain has a very little implications. There's a big thing around compliance, anti-money laundering, movement of money, and storing that into blockchain. Financial services is obviously have been in there, so this traceability, they like the audit, the traceability of these individual items. So you have some of that component. Healthcare we've talked about, and then your insurance companies, hybrid, that are technology oriented. Many insurance companies used to be on every street corner. Now they've kind of merged up, and you've got these Geicos of the world and organizations that will service you completely online. But those types of organizations are really coupling it up with the smart contracts. So they're putting everything out there so that if I get in an accident, I can somehow share my insurance background history with your records. So you would hope that you would collect that at the point of accident. And so some additional components that kind of breaks that down, there's really 4 key areas. So you looked at those are industry specific on the last slide. These are really looking at the idea of 4 key components. There's smart contracts, that's actually the legal and escrow, wages, some of those things. You have your digital currencies, which was kind of the earliest adopter, but it's been somewhat slow because many countries were even looking at what can we do to prevent more Bitcoin coming in because of transfer pricing, because of taxation issues, some of those concerns that came out. And then you had record keeping. So this is the kind of what we talked about, the healthcare, the titles. This is where your education records would go. And then obviously securities and financial space where you had some of those components. Some that's been really big adopters of this is actually a lot of the crowdfunding. So this is kind of neat modeling. So, ultimately I'm going to get money from individuals that want to fund other individuals. And I want to build, have those things build out from individuals that want to fund it, and they can actually easily do that through crowdfunding. And so my last really slide around this is really looking at a case study. So this is a case study that I work on when I'm not teaching classes all the time and trying to really aggressively keep forward, but it's one of the things that I have the ability to do is actually work with the foundation. And one of the things that I do is kind of manage out their research development for I'm a fellow for the Bill and Melinda Gates Foundation, and they've partnered with National Student Clearinghouse. That organization, every student record, they have 98.6% of all student records goes into a data repository. And they're very secure. The reason they were built was because they provide that to the federal government for lending purposes. So they would say, has a student attended before, or are they a first-time student? So they do all of that type of work. And Elon is a big participant. So we send all of our data to the National Student Clearinghouse. So one of the things that they do, they have records that go all the way back to the 60s. So anybody that's attended any institution back from the 60s forward, your records are there and they're in their repository. So one of the things that the Gates Foundation really was interested in is how do we use blockchain, and how do we use blockchain in such a way that we can move education records? And we know that, who's going to fund, they're funding this, and the magnitude of double digits on camera, I don't want to say too much, but double-digit $1 million they've put in this for a 3 to 5 year contract. So they've put that money out there and said, here it is. And that doesn't even include the money from their fellows and everyone that they're putting for the project. So what they did was they went after, selected this organization, and what they're looking to do is to automate student transcript automation, so your movement of those transactions through a blockchain, helping with enrollment trends, helping with academic portability. So they realized we don't have that too much at Elon, but 40% of college students start at a 2-year institution and then go to a 4-year institution. So the number of transfer students is picking up. And the other big piece that they have at the end of our project, so we've got blockchain built, we've got the records in there, but they want some machine learning built in there. So something that helps a student to see what will my financial debt be at the end of this time, from if I go into a graduate school or a PhD or whatever program of study you would like, or professional studies, and what's the likelihood? Now this is the one that gets risky, but they also ultimately have it in there, is through machine learning. What's the likelihood that my background with my records will complete this program? And it asks a series of questions in there about, like, what are you planning, or family planning, those types of things. And they allow for tweaking throughout there, because your life it's not a given moment in time. You can't say what you're going to do in 3 years, but they can actually create some early indicators in there. But it's built on a blockchain that you, the student, owns, and you can share that with whomever you want. The name of it is actually this My Hub. I did not name that, but that's what they called that, My Hub, and it'll be completed in 2020. So it had some challenges, which is really this, adoption of it, and then it creates disruption to the marketplace, right? Like, so students, when you are an Elon student, you come to Elon, you request a transcript, you go to the registrar, you request it. registrar goes and gives it to this third party called Parchment, they send it over. I mean, that's how that works today. So it actually had some objectives, but what they're looking at it is really mobilizing education attainment and really allowing you, the student, to have full control over where your records go. So that's kind of a use case of one that will use, that is built on the blockchain technology. And that's kind of the infrastructure and will be maintained long-term from that infrastructure, to allow you to basically share that, build your own history with it. Any questions about that? Yes?
On that. Give an example here, obviously for the student clearinghouse, and you also mentioned something earlier about how, say, advertisers could build, blockchain based upon your preferences and such, and have some personal information about you. And obviously, this would as well. How does that fly in the environment now of GDPR and the right to be forgotten and how that's spread around?
Right. So GDPR is around really heavy built around public directories and really looking at public directories. Came out of London, but really built out of public directories. It was actually one that as soon as that happened, they were like, all the people in this project. I mean, Gates was like, here's the money, book flights tomorrow, and we all went and flocked into we were all in New York City for a couple of days. We all actually I went to London in the spring, last June, where we talked about kind of what's the ramifications. So really the idea is that you have to give people more preferences. And really the idea there is give someone the preference of public directory. So do I want my information? So it used to be years ago in many organizations, many education institutions is a great example, healthcare similar, used to basically, as soon as you got accepted into an institution, you sent your enrollment, you showed up in this directory. Oh my goodness, my public information, my home address, or whatever address you used, showed up in a directory. So now they give you more of a control. So it was the idea there is a mandate that started last May that was really designed around helping organizations to think more creatively and more structurally. How do I allow an end user to opt out of their information from being publicly seen? And so the idea behind this blockchain, this is a great example of a blockchain, but it's the idea is the student information sits in there. The student can actually elect to lock that down and shut it down where no one can have access. And that's one of the options and a preference. So when they go to set it up, shut everything down. Or if they don't shut everything down, the default based on GDPR is everything is shut down. And then the student goes in and enables it. They say, I want to give these two people access. The other thing GDPR said was, I can give you a limit to when you have access. So you can get an access for 2 years. So I'm going to give Elon University, that I'm applying to be an undergraduate, 2 years of my history so they could see 2 years back. This is a problem because people like Elon say, I want to go back further. Give me more. And so the technology will do what you tell it to do, and then the institutions or providers can come back and say, I need more than 2, I need 7, or I need 8, or I need 10, or whatever the case is, and then you would then have to, as the user, would have to re-enable them. So there's no public directory, so to speak, coming out of this technology. It's more of a student sits with their information and they say, I want to share it with you, and you specify that in there. But there was a lot of implications that we had to rebuild because of GDPR originally.
What about the entities where they don't have control? Like you mentioned, the advertisers.
Right.
You never ever know that a certain set of advertisers has this blockchain based upon all of your preferences.
So, right, so GDPR in that particular respect, there's no directory so much, so to speak. They are actually selling, that data is being sold as a closed channel sale, but what's happened is the collection of it is open-ended, but what ended up happening that you may all notice is GDPR actually started this as well. When you go to websites, a lot of people get annoyed. They say, gosh, on every website I have to accept the cookies now. And if your alternative is if you don't accept the cookies, you leave the website. But ultimately, everybody has set their websites up with these cookies that basically you have to accept or say, okay, I agree that you're tracking me and you enable you to collect cookies on me while I'm on your website. So some of that was built out was just around transparency, but a lot of the concern around that is that a user that wants the content on that website almost is having to be forced to waive their rights in order to use the technology. So that's the other side of that, but that's one that's going to get much deeper over the years, because everybody now it's opened Pandora's box around transparency and what your information, but everyone's required, and this system's the same, and so blockchain can do this for you. Everyone is required to keep an auditability or an audit trail, so that if you call a marketing company, if you call Newstar right now, or you call any of these providers and you say, I want to know everywhere you gave my information. Now, some of these providers have actually gotten really smart about it. They say, I won't give you a name of a person, but I will give you a zip code that actually will have the person that will buy your BMW. I will give you a zip code, and I will give you even closer than that, I'll give you a census area that's even tighter than the zip code that will allow you to find the people. So that's one of the things. I mean, yeah, there will be some changes there. Yes?
It's kind of like a regulatory mess, like, in general. So how does this is this sort of like a Uber-style thing of do it and ask for forgiveness? Or, like, how is the government being involved in this whole sort of blockchain conversation?
The government's actually investing in blockchain, and the first Thursday of every month, they meet at a place called L'Oreal Plaza. It's a restaurant, a Mexican restaurant in DuPont Circle in DC. But they are, and I've been to a couple of those, but it's basically, they're really looking at blockchain as their future, because it enables, it's more secure. I mean, it's actually more secure than the technology that they were using and putting things in public directory. The IRS is one that we've talked to about blockchain, or I've been in conversations. They're doing a lot of exploratory. They have not yet invested. They've got so many technologies that they're behind on that they're just putting their interest hat into. So we will still have time at the end, but I want to turn it over to Sam, and I will load your presentation for you, Sam.
Thank you very much. So about 2.5 years ago, the executives asked me to put together a presentation about Bitcoin. And the reason they wanted to do that is some more from the regulatory side. You know, what happens if we have to do, we have anti-money laundering product. We also have KYC. I don't know if you're familiar with KYC, but the banks are all required to do KYC. So if you go and open an account, they basically ask you everything you can imagine, and whether you bought a vacation home in a OFAC country like Cuba or something like that, they kind of frown on that stuff. So the question was, how does this Bitcoin stuff all play into that? So I started with that and took a look at it. One thing I'll say up front, and I found out later from the Treasury Department, that all these cryptocurrencies that we're going to talk about a little bit are considered unregulated currencies. So banks don't really worry about them right now. They can't deal in them. They can't transfer money in them. They can't, because, again, they are considered unregulated by the feds. So I was in a conference with 500 people in the room, and she said, just remember that these are unregulated currencies as far as the government's concerned, so you can't deal in them. I thought she was going to get stoned right there by 500 people, because it was a blockchain conference, of all things. So anyway, I took that data and I was looking at it, and I said, well, let me see if I could do something else with it. And SAS, are any SAS programmers in the room? All right. SAS has a product called Visual Investigator. It's used by police departments, child welfare organizations, and things of that nature. And I decided that, what happens if you had to do an investigation and you found out somebody had a Bitcoin address? What happens if you want to include those transactions? Well, I started to take the blockchain and put it into SAS data sets. And at a rate of about 5 terabytes, I realized that wasn't such a good idea, because at the end, what was I going to prove? So what I did is I found an ID. I found the WikiLeaks ID. I don't know if you know about WikiLeaks. It was kicked off of PayPal in 2013, so they went over to Bitcoin. So they do all their funding through Bitcoin. You can find the address, it's published, you can send them money. So I took about 28,000 transactions that they had done since 2013, and that was last year, so they've probably done a lot more. They're running about $40,000 through their account a month, in and out. So I took that and I pulled that data in and I put it into our visual investigator as a use case. So let's say you were investigating me and these were my transactions. So I was able to pull longitude and latitude information, so I had this pretty picture of where all the transactions pretty much came for on Bitcoin, and what I found out was they come from everywhere. And the other problem you have is that's one address. Probably they have hundreds of addresses, and anybody can have those. So there's a lot of challenges in that space, and as I was working with it, I discovered that I was able to put it in to do some analytics, some basic analytics on how much they spent a month, how much they spent a quarter, what was their final rate. Because the nice thing about Bitcoin is you can find every transaction. It's back to what they call the Genesis block, which is the first block they created in 2009. Bitcoin will be 10 years old in January. So what is a blockchain? I think Joe talked about this quite a bit. It's this thing called a distributed immutable ledger. And so Bitcoin created this. It's the grandfather or godfather of all blockchains. So this whole idea of a ledger and a data store. It can maintain anything of value. Of course, Bitcoin does one thing. It does transactions. That's all it does. Now, you can add other data into your blocks, but typically you don't because there are some limitations to that. It's basically a linked list of blocks of transactions. So when we look at how it's organized, it's very simple. It's not a terribly complex structure. But it's a linked list of blocks that is basically a linked list of transactions. It's secured by asymmetric cryptography and hashing. That's the whole trick to it. But the real thing it solved is this thing called double spending. So just like when you go to an ATM, you can take $1 out. You can't go to the next ATM and take the same dollar out. You're always taking, you can't double spend. It's the same idea in Bitcoin. And they solved this problem. So or any of the cryptocurrencies, they're all pretty much ledgers. So this was a big step for them. I mean, that was the biggest problem. That's what banks have spent millions and millions of dollars doing in these databases, is ensuring that there's no double spending. So you can look at that. This is just basically a simple diagram of what the transactions look like in Bitcoin. The below are Bitcoin addresses. It's really not terribly complex, but it's very secure. Now, one thing I will say about Bitcoin, they're having a lot of performance problems. They're going to continue to because they just have so many users on there. 95% probably of people in Bitcoin are purely speculative. They don't use it for transactions. But if you could imagine if somebody like MasterCard or Visa dropped all their transactions onto Bitcoin, it would bring it to its knees because Bitcoin can only do 7 transactions a second. So it's not considered a high rate, where Visa may get 20 million a day, to give you an idea. So let's talk about blockchain components. And the reason I'm going to do that is because when I get into the analytics discussion on how you can measure analytics on a blockchain, we're going to break it into 2 pieces. There's wallets and clients. As you know, when you use Bitcoin, whether you do it through an exchange or you download software and create your own wallets, this is how you create and originate transactions. There's this Bitcoin and a lot of them, Ethereum, Litecoin, all these coins are considered broadcast blockchains. And the reason they're broadcast is once you put your transaction in there, it propagates your transaction across all the nodes in the network. And the reason it does that is because the miners all get equal access to the transactions. And the miners is what controls consensus. So the miners collect these transactions, they build blocks, and they start a consensus process. Bitcoin, Ethereum, Litecoin, Monero, Zcash all use what's called proof of work. And it's basically it's like guessing the lottery. So they have these hashing machines that constantly, they have
They give you a result. They call it a mathematical puzzle, but it's not. All they do is guess at it. They just guess and guess and guess and guess until they get the result which is required. They get 10 minutes to do it. If someone does it before then they get it. And whoever wins the mining gets 12.5 Bitcoin right now, which is, that's $80,000, $75,000. So consensus is the proof of work, and Ethereum's trying to move to proof of stake, which really means whoever has the most money gets to do all the mining. So this is the protocol side of it. And the last piece of it is the data store. Now, everyone says blockchain's a data store, it's just data. It's not. Blockchain is made up of all these components, and I call the ones at the top kind of the moving parts of a blockchain, and the data store is basically what you know, what stores the data itself. It can be anything binary. A lot of your permissions use key value stored databases, and some of them even use document. Big ChainDB uses Mongo, which is considered a document database. So what types of blockchains do we have here? Joe mentioned 3 types, but I'm going to break it into 2. One is your public blockchains. These are cryptocurrencies for the most part. They're distributed, so no single point of failure, and they have an anonymous, pseudonymous identity. Bitcoin keeps no information, doesn't know your name, doesn't know anything. The other side of it is what we call the permissioned or private or shared blockchains. This is your Hyperledger. These are the ones that are open source and more your enterprise level. And the big differences are they use a database. They physically aren't, some of them store binary, but for the most part, they all use databases. And they have known identity, so they keep track of who you are and all that type of information. There's lots of projects going in there. You talked about healthcare. One of the other things about the healthcare records is as you get old like me, all your health records are going to be collected. And if you've used a drug, there are going to be companies that are going to want to understand how you use the drug, and you can release that information without them knowing it's you, and you can actually get paid for your data. So there's a big side of that stuff with these type of blockchains. They share a database, and they're behind firewalls. So banks are not going to create distributed blockchains. They may distribute in their data center or multiple data centers, but they're never going to open it up to the world. I mean, that's just the way banks are. They're very protective about data. And I've worked at a lot of banks. You use new batteries. So let's talk about the blockchain landscape. Cryptocurrencies, that's what everyone knows, the cryptocurrencies. There's over 2,090 cryptocurrencies. Now, if we're going to do AML or we're going to do any kind of regulation on that, how do you do that? But of course, Bitcoin still is 52%. If you take all the capital value of the cryptocurrencies, Bitcoin makes up 52% of it. And the interesting thing here is, these are all those initial coin offerings everyone hears about. I met with the SEC earlier this year, and they're scared to death of these things because you and I could go out and get on Ethereum. They got a project ICO, which is a bunch of smart contracts where you can create your own currency. Then you can start writing emails to anybody who wants it, and they can actually, if you go to an exchange and buy your currency, you have the currency. There's no reason for you to pay them back. I mean, once you have it, it's yours. So there's a lot of concern because the SEC is concerned about the fraud side of this piece of it. 80% of funding for ICO, venture cap, for projects on blockchain now is all ICOs. So you have a great idea, you go and create your currency, people donate to it, you're successful, the currency has value, they sell the currency, and they're millionaires. Any Bitcoin millionaires in the room? 2011, you could buy 3 for a penny. So you're going to see a lot of this. And I think one of the reasons for this is if you can create your own coin and people can buy the coin, it's easier to do it that way because you have volumes of people. There was a gentleman in college who was at a football game, And what he did was, he took his public key, which is what you use when you want to transfer money back and forth, put it on his shirt. And he held a sign up that says, "Mom, send money." Well, people took pictures of that QWERTY code. In a period of 2 months, he had $11,000 worth of Bitcoin. Because it was just thousands of people were sending him 50 cents or a buck. It was never a lot of money, but over time it contributed. So there's an idea for you in the future there. Blockchain projects, enterprise. There are just a lot of, this is where a lot of the stuff's going on. And from a SaaS perspective, you know, we're not going to really look to do analytics on cryptocurrencies. Everyone's doing that. I can go to any one of the conferences, and there's hundreds of companies there doing different forms of analytics, more from the financial side. R3 Court is another one that's very popular. There's 4 popular ones, basically. But there's all types of projects going on in this side. And I think if you're going to get into blockchain from a chance for opportunity, I think the enterprise projects for me. Digital ledger technology investments. Joe mentioned Microsoft. Microsoft Azure has blockchain as a service. So does AWS, although AWS is a little raw. But all these companies are big into it. I think PwC now has their own blockchain also. Open source blockchains, there's lots of them. So, you know, when I'm looking at the landscape, the purpose of this is, if I get into a project where any one of these are available, how do I deal with the analytics side of it? And I've met with some of these people at the conference that have built these blockchains, but this is just a few. There's probably 30 of them. Another thing you want to remember too, when companies pull these open source projects in and they put them inside their company, they change them. They don't put them back in open source. That becomes their intellectual property. So you're going to see, even though these are the starting points, most of them don't do that. Sawtooth is Intel's. Hyperledger's, IBM runs that. Ripple is a bank. The bank payment system is trying to replace this product called Swift. So what are the challenges here? Blockchains implementations are very diverse. You can look at every blockchain in open source, and not a single one of them is going to do it the same way. And not a single one of them is going to use the same data store. So you really, if you're going to do analytics in these environments, you really got to be flexible in the way it's handled. Programming languages. There's lots of them. How many people have heard of Kotlin? It's a JVM language that's written by the company who developed IntelliJ. JetBrains is the name of the company. So there's the R3 Corda is written in Kotlin. So you have all these different environments that you have to integrate with. So there's a lot of the Go language. Bitcoin has a version in Go. That's a Google language, and of course everyone's heard of Java. So the protocol side of it is consensus and defining wallets, mining processes. These are some of the challenges. They're all different, and every single one of them can be a challenge as far as how do you get analytics out of that. The data stores themselves can be binary. Most of the permission versions are NoSQL databases. R3 Corda is not even a blockchain, although they call themselves a blockchain. They create these things called vaults. So if you and I create a transaction, you and I can see that transaction, but no one else can see that because they put it, just you and I would have it in that blockchain. And encrypted. You know, if you're looking at some of the cryptocurrencies from a regulatory perspective, Zcash basically encrypts the whole blockchain. When you transact, you can see, but once you've done transacting, it's pretty much all encrypted. Servers. So I don't know if you've heard of Kafka, Zookeeper, and databases. All these permission blockchains use some form of database or use these server. Kafka's a message server, message bus. Zookeeper is a management process software. So these things are the things when you're doing blockchain analytics that you're going to have to deal with. So this will give you an idea what a blockchain basically looks like and all the components. This is the one that I actually developed, but just to give you an idea, and we'll talk about this in a minute. So from a blockchain analytics, you break a blockchain into two parts. I look at a data store and the protocol. And if you take all the different combinations, and this is my little math problem. My dad was a math teacher, so he'd be proud of this, I think. Anyway, the bottom line is there's lots of combinations. And when you're working with projects with customers or you're walking into this, you really want to understand what they're working with and how can you easily connect to each one of these. So what was my objective? First of all, I want to take a look tactically. So if you look at the protocol side of it, I honestly believe you can do real-time event-based transactions out of your blockchain. And we want to use a streaming engine. SAS has a great event streaming engine. And I'm working with some other colleges to doing some hackathons. So not only will they hack smart contracts, they can also connect it with the event stream processing. I honestly believe this is where your opportunity is in analytics, because once it's in the blockchain, you may not even be able to read it. It may be encrypted or it may be difficult to read. But if you can define events in the blockchain and make changes to some like the wallets and the miners, you can send events out. You can pretty much track anything you want. And of course, with our SAS Via product, which is our new version of SAS, you can actually look at the data store. With a little bit of effort, you can do it. When I did Bitcoin, I had to write a bunch of Python code, but I got to work. Analytics, design, and perspective. So you're going to look at the blockchain that I have, that I wrote, was basically purely to demonstrate how to capture analytics in the blockchain. It wasn't designed to be a ledger. It's not a ledger. It wasn't designed to be a product. AI and deep learning models. I think these things are going to really be big in blockchains. Now, all your blockchains pretty much are hard-coded. Bitcoin is going to do mining every 10 minutes. If it gets shorter, it will make the problem harder, so it goes back to 10 minutes. But a lot of your blockchains in the future, I believe, are going to have deep learning models that sit and watch the blockchain performance and eventually feed back to the blockchain and say, you either need some more processes or you need to change the speed of your consensus processes. So I think that's going to play a big role in it. And also in the data side of it. So if you're a company and using a blockchain for order management, you're going to want to know where all your orders are taken. You're going to know which part of your blockchain is taking most of the transactions. These things they do this now with existing systems. So there's no reason, because it's a blockchain, they're going to change their ideas on this. So I created a proof. And my proof, as you see in all the things about blockchains, had to be agnostic. I didn't want to say, hey, this only works with Hyperledger, or this only works with R3 Corda. I wanted it to be non-intrusive. I had to prove that it could be non-intrusive. So the worst thing you could happen to a blockchain is if you add events, it slows it down. That could be the worst thing that could happen. So I had to prove that it was non-intrusive. I had to be able to handle multi-industry test cases. In this case, I have IoT. I'll talk about my IoT example that I have running in a blockchain. Transportation, and this is, and I'll talk a little bit about that, is got to do with people who get those little scooters, and they go somewhere and they park it, and then they get out for that, and they get in an Uber, drive 5 miles on an Uber, and then they get out of the Uber and they get on the train. They get on the train and they drive the train, and they get off the train and walk to work. So there's a whole consortium of people that are actually trying to track that stuff so they can manage cities, right? So they want, if you look at any of these companies by themselves, they have great systems,
But what they need to do is create a blockchain that sits over top of all of them, where the Uber can send when the event happened, when they arrived. The train systems have great networking software. They've been writing it for years. But when they get on the train and when they get off the train, they can add events to the blockchain. So at the end of the day, the blockchain didn't touch any of their intellectual property, didn't go into their systems, but it basically offers everyone a picture of how the people are moving within the city. And it's probably going to work in Europe before it works in the US, at least in North Carolina. I also wanted to do full hashing and crypto functionality. And the reason I did that was because I wanted to really test all the math of a blockchain when I'm doing my analytics. So if we were to hook this to a Hyperledger or some of these other blockchains, it would work. And of course, confidentiality, scalability, risk, and governance. So if we talk about confidentiality, and I think this is really going to be big in the IoT space. If you have an emergency room that has all these devices and all these people in there hooked up to their devices, and these devices are dumping IoT transactions off into a blockchain. But each device has its own private public key, so it's actually encrypting every single transaction that goes in the blockchain. Now, what's good about that? Well, the people who know what the hospital knows what person's on that bed and what person's heart they were listening to. So it knows it was me they were listened to. But in that blockchain, they don't know anything about that. So the beauty of that is you can take that information in that blockchain, and you could, if HP, Hewlett-Packard created the device, they could take that device and do analytics on that without knowing who they were listening to. And I think that's going to be big. Scalability, blockchains in permission space are going to be put into containers, and they're going to actually run from a container performance. And I've actually got a blockchain running in containers, so I can actually scale it manually. But it'd be ideal if I could feed AI, deep learning information back to that and increase or decrease the size of my blockchain. Risk, of course, that has to do with the whole encryption and cryptography side of it, and governance. Every organization's going to want to keep an eye on their blockchain, especially if they're getting revenue off it. Don't let anybody fool you that this is going to be like the wild, wild west of Bitcoin. But it's not going to be. And IBM, for example, is spending a lot of time in this space on their Hyperledger project. So from an analytics perspective, I'm going to focus on real time. I think that's really where you're going to have a lot of opportunity, because you can catch any kind of event. Customers, users of blockchains can define when they want to do other events. We also want to look at the immutable data store, so you have historical type reporting. We want to look at operational and informational. So if someone's taking orders on the blockchain, we want to make sure they can take the orders. That'd be the operational side. And the informational side would basically be, where am I making my money on my blockchain? AI deep learning, this is basically, as by definition, is continuous improvement, looking at content recognition. In the case of our event stream processing engine at SAS, you can do text analytics. All that stuff's built in. So once you put events, that data into it, you can do all types of analytics on it. And recommendations. You want to use these AI deep learning recommendations to feed back not only to people, but also to the blockchain for performance reasons. So this is my architecture layering. I've been probably an architect longer than I've been a product manager, well, that's for sure. But anyway, this basically gives you an idea how I put it together. The bottom layer are connectors to blockchains, and they could be events, they can be connected into the actual components, could be a library connecting to Hyperledger. This event blockchain is something that I put in there. This is the blockchain that I built. And I'm actually looking at doing some SAS programming for smart contracts. I think event contracts might be pretty cool. So I've got some work to do there. The streaming engine, my little blockchain uses a consensus, response request consensus process with the event stream. It's very fast. So I get very high rates on that. And obviously the deep learning model built into it. And then there's a whole presentation layer. If you don't want my blockchain, you can connect it to any blockchain through a lot of this, through these different layers here. So how does it fit into SAS? Well, this is the SAS ecosystem. One of the sales engineers in Italy put this together. But anyway, it shows you the blockchain, how you're putting events out of the stream logic side of it. You can actually do the API side at the bottom, is more going after the immutable data store. And once you get it into the dotted lines, the SAS ecosystem, you could pretty much do anything with analytics possible. We've been doing this for over 40 years, and we've got a lot of great products along there in that area. And of course, fraud, risk management. This is what a model looks like inside the streaming engine. These blue circles are actually called windows. So each one of them makes requests, and you can see I've readies, completes, and all that kind of stuff. So you can actually see the performance right inside the model inside of our event stream processing. So this is what it looks like. It has 3 components to it, basically, 4, counting consensus. Each one of these miners make requests into, publish requests into ESP. Consensus reads the requests and hands out tokens. So only one miner can update it at a time. So it's pretty cool. It's also, it's not a broadcast blockchain. It's basically a, it's a request basically type blockchain. So the miners pull all the data in, and each one of them, the node controllers round robin to each one of them. And so by doing this, I have lots of events coming out of this. Now those little pictures at the bottom are IoT devices. So I had to prove that this thing was fast enough for handling any blockchain. Those IoT devices, when you move them, it's like your cell phone, gives azimuth information, rotation, gravity information. I have 2 of those, and I connected them up to a Raspberry Pi. And the Raspberry Pi sends events to the client, which does all the encryption and sends it over to the blockchain, over to the miners. Miners update the blockchain, and they put the data also in ESP so you can do analytics on it. What I found out is these little devices create events every 9 milliseconds. So with that, every 9 milliseconds, that I'm updating the blockchain every 2.5 seconds, as opposed to like Bitcoin does it every 10 minutes. So this was really a test that we can do analytics at speed in any of these type of blockchains at those speeds. But it was kind of cool because you could actually, there was no latency. I could rotate it, and you could see a graph of it, of the rotational information, and it was updating the blockchain at the same time. Future thoughts. Blockchains. When I originally started looking at blockchains, everybody wants a blockchain. It's great for government, it's great for healthcare, but the problem with it is like a hammer. When you have a hammer, everything looks like a nail. So there is a problem with that to start with. But I think this ledger thing's the same problem. Because all these blockchains are ledgers. Now, ledgers are great. And IBM uses a use case where they transfer oranges from Florida to New York. And when they do, oranges will go through by train, they go through 13 train companies before they get to their destination. And when they get there, 30% of the fruit is spoiled. So what they've done is they've introduced a blockchain. So they create ledger transactions in the beginning, and then every time they transfer between companies, they create another ledger transaction. It makes perfectly sense. But if you have all these IoT devices, and they're sitting there spewing events, are they ledger transactions? I don't think they are. So what they're doing is keeping track of temperature. But could you imagine if they were transferring cars and only 70% of them made it there without being unusable? So I really think in the future you're going to see a lot of more non-ledger transactions. My blockchain is what I call a payload blockchain. So anything you put in it, it puts it in the blockchain.
high throughput is going to be critical, and they're doing a lot of work on that. I think R3 Cord has done some interesting stuff with that. Data integrity. I think blockchain is going to be used for data integrity a lot. So we talked about the hospital, how events coming off these monitors going into the blockchain. One thing you can guarantee is because there's a signature on it and a public key, you can mathematically prove that it came from where you think it came from. The second thing is that the whole record, the whole block is hashed, and even the records themselves, like Bitcoin, have Merkle roots on them, so you can guarantee when you get that data, you can run it through a mathematical function instantly and know that that's a valid block. So you can actually be able to load data in from anywhere and be able to prove that it's valid data all the time. IoT will drive performance. When your refrigerator's telling you need to buy eggs and all that good stuff, it's going to happen. Blockchains will connect multiple companies. I think you're going to see a lot. I think, especially in the area of know your customer, where banks have to know whether you're, a terrorist and things like that. If someone were to come in and they can't verify it, I think they're going to share that information with other banks, and it might be through a blockchain. Very ideal for that. In industries, I think you're going to see a lot of that. Data and blockchains will be dissimilar. So right now, if you look at most of these blockchains, a lot of them are, especially the currencies, are all monolithic. They store one thing. But I think you're going to see blockchains in the future that'll actually be able to put pretty much any data in there that you want to. My little blockchain does, but mine's also not a ledger. So I think it's going to be a combination of the two. And of course, my next steps on it are actually to connect up to some of these live databases. The reason I created my own is because I didn't have time to pick one of these and, and learn it and get it working. So, and I think that's it. Are there any questions? Are you awake?
So, Sam?
Yeah.
Would you please talk about the blockchain that you have created?
Okay, sure.
The purpose of it, what it's allowing you to do that you couldn't have done without blockchain?
Okay, let me see if I can go back to it. So a picture of it. There we go. So this blockchain here basically is an event-based blockchain. So these clients, each one of these clients has their own private public key. So do the node controllers, so do the miners. So when a client, like a transaction or generates an event, in this case it's just events, transportation data or IoT data, it encrypts it and sends it to the node controller. And the node controller re-encrypts it and adds its packet information, and then it goes to the miner. So by the time it gets on the blockchain, these transactions gotten a lot bigger. But the reason I did it this way was how I know the exact travel of every single transaction, what node control it went through, who owns it. All these miners also have their own private public key. So everything in this, so the real purpose of that was to prove that we can operate at speed doing still all this encryption. And I actually used the Bitcoin algorithms, which is called a Koblitz curve, for those who care. And I also used the same hash 256 that Bitcoin uses. So I used all the libraries. The clients are written in Go, a language called Go, and the miners are written in Java. Blockchain is MongoDB.
And the business purpose of it, so I know it was about...
It was a proof. It was a proof originally. But now that I can put anything in it, I'm working with the opioid abuse data that's coming out of the different states. They're all concerned about that. And I think blockchain would be great for that, because then each one of these pharmacies and miners could have their own private public key, and they could generate, every time a prescription is sent, they encrypt it and send it over with their key. No one knows that data. You can give that data to anybody and let them do analytics on it without knowing who the source is. One of the problems we have, we're working with a state agency right now, and they're real concerned about obfuscating all these IDs, because if you got the ID, it's kind of like Social Security number. You know
who the person who's receiving the drugs. But by putting it in this type of a blockchain, what I've done is I've actually used a private public key to generate a signature, and that's how it works now. So, but no one it can prove by doing the signature in the public key that it's valid, but you don't know who its sources is. And that's why I like this payload idea, because it's not a ledger. You don't really need ledger transactions for every single one of these. But the other thing too is, this is a registration blockchain. So no client can send a transaction without it being registered. Because every time it comes in here, when it gets to the miner, it sends a pass-fail back to the previous process. So when the event comes in here, if it doesn't, inside the event stream processing, you treat it like a little database. So it'll actually, every transaction has to match or does a join on a registered entity. Of course, mine's in test now, so anybody puts a client up there, it's registered automatically, but that could easily be controlled. So where you see Bitcoin controls it through transactions and through the keys, a public key, this one basically is a registration type blockchain where you would have to register. You could have put another process out here that basically is an administration type client, which basically says, okay, I'm going to be able to register this stuff. I think you'll see more in those two. They're very key. And then I only keep the key, the public key, but you could keep any. You could add data to that administration function and put that in the blockchain also. So, anything else? Well, it's kind of technical, I agree. I think I'm going to need to change it around a little bit more for the folks. This is much more of an industry type presentation, but I will work on that.
That was great.
Sure.
Definitely learned a lot.
Yeah, sure.
So-
Yep.